Hey guys, today we're going to learn about sockets programming in Python. So Python sockets programming. So you'll see here we have, we're going to use a few test scripts, and the first one is the client script. And you'll see this is up on the screen right now. Now this is the most ridiculously simple client we could possibly create. And you'll see, so I'm going to run through the client and then I'm going to run through two servers. One server is not multi-threaded, so it can only take one connection at a time. And the other server is multi-threaded, so it can take multiple connections at a time. That's why I have two other terminals here in the back. I'm going to run two clients at the same time and show you what happens. So let's go through the code for the client first. Then I'm going to go through the code for the two servers, and then I'm going to demo the two servers. So the client, basically we define the host. It could be the IP address or the host name, and I'm putting this in a variable, and I'm just using 127.0.0.1. That's the IP address for the local host, so that's the current box that I'm on now. So I'm going to connect to the same physical box that I'm on now, but you could just as well connect to something remotely over the network or the internet. But that's basically the same mechanism. Anyways, I'm assigning this as my port number, just 1, 2, 3, 4, 5. So I'm saving those both in variables, and then I do a with open. Right, I do a with socket.socket. First parameter socket AFINet, socket sock stream, and you're pretty much always going to just specify those, and that's coming from that's a call coming from this thing that I imported. So you'll see I imported two libraries, time and socket. So time is just so I can use the sleep function further down, and socket is to do all of our sockets related stuff. So when you run this with socket, you're creating a new socket and you say as s. So the variable s is what holds your socket. And then I'm going to do an first thing you're going to do is an s.connect and specify the host and the port that we defined up above here. So this is going to connect to the server, and that does your TCP connection. We're using TCP, and that does like the three-way handshake and establishes a connection. So then you're going to do send all, and you're going to send you're going to send this string here, hello world. So we're just sending a quick hello world just as a demo. So this is like the hello world of sockets programming. And then so you send that to the server, and then you're going to receive. So on your sockets variable, you call the function receive, and you pass 1024, and you tell it to receive data, and we're going to assign that. Once it receives all that data, it's going to be assigned into here. And I believe what this does is it takes at most this much data. I could be wrong about that. I should look that up and specify, but yeah, in any case, if it's less than this much data, it's just going to stop when it gets to the end of the stream. So this is just going to pull however much data the server sends to us. And then it saves it in this data variable. And then it prints it out, and it says from server, and it prints out your string right here. So so it basically prints out the data that's sent back from the server, the response that we get. Now our server is basically just going to send the exact same string back to us. So we're going to send the string to the server is going to send it back. So it's the most simple thing I could come up with. And then it's going to do a sleep for 5 seconds. Now normally, like you probably want to just kill the client at this point and have it disconnect. But I made it sleep so that way I could run two clients. I'll run this client, and it's going to stay until this sleep is done. It's going to stay connected. So this with block, it's going to stay connected to the server until either the server disconnects or we disconnect at the end of the with block. So once this is done sleeping, it's going to disconnect. That way I can start up a client from here and here at the same time, and we can see them both being connected to the server at once, even though the time it takes to actually send the data to the server and get it back is like a fraction of a second. We're going to leave it connected for 5 seconds. That way we can launch two of them and just test it out to see two things connected to the server at once. So I'm going to get out of here, and we're going to take a look at what's in this directory. Now we'll see we have the client program, client1.py, and server1.py. PY and server 2. Server 1 is not multi-threaded, server 2 is multi-threaded. Now I should mention I'm using Python 3. I had some issues on the client with Python 2, and I think some of the parameters are different. So just be aware that these code examples are, they're tested with Python 3. You're probably going to have to change them if you want to use Python 2. You should be using Python 3, but at this point anyways though. That said, if you want these code examples, check the link in the description. I'm going to have a link to these code examples on my site. So let's first take a look at server 1. I'm going to try to go through this quickly. Server 1, all right, so enter, all right, so now I zoomed in on this a lot so you can see it in the video, but it kind of crammed the code into one thing, so it's a little bit messy, so I apologize for that, but let's see here. So we're going to go down to, so here we specify the host, we leave it blank to listen on any IP or interface. You could tell it to listen to a specific interface. I set the port to the same port that the client uses so that they can connect to each other. Now here, first thing you do is open a socket. Notice we're not using the same parameters as above, as in the client. Here we just say socket, and then I imported socket. It's the only thing I'm importing. So from socket we call a socket, and we call this socket method, and we assign it to S. So that's our socket. Now to listen on a port, it's a little different from connecting to something. First you want to bind to the port, right? So from S you call the bind function. So call bind and pass the host and the port you want to bind to. And then from there, once you've bound to that host and port, from your socket S, you call listen, and that just tells it to listen. And I think this was required before Python 3. I forget if that's the case, but I put it in my notes here. So basically this tells it to start listening, and it's optional in Python 3.5, but this is the backlog for pending connections. So this is only going to allow that many connections pending to connect to it. And what else? So that's how many connections can be queued up, and I believe you could remove that to make it unlimited. Let's see. So then once it's listening, we're gonna print out saying, hey, we're listening on this host and port, and then we're gonna do a loop for connections. So we're gonna loop for connections only one at a time. So we have an infinite loop here, and when it's disconnected, actually don't believe I have any logic to disconnect the server. The server will just run forever. So loops forever. And on each loop through, it accepts a connection. So we run this s.accept, and when a connection comes, that will block and wait for incoming connection. When a connection accepts this, that it will continue on, and that's why you would need to be able to accept multiple connections at the same time to be able to have multiple things to connect to this. This only accepts one thing. Once it accepts the first connection it gets coming in, it's going to move on in the script and not be accepting more until that connection closes, and then it moves back up to the top of the loop. And we're going to have a fix for this by multi-threading in the next example. I'll get to that in a bit. So inside here we have another loop to receive data, and so this loop will it's another infinite loop, and basically you're going to receive data. Once you accept a connection, you're expecting data from the client. So similar thing, this is the exact same call we used in the client to receive data. Receive 1024, that's just a nice size of chunk of data, nice even number. So and that's why we picked that. We could make that a different number, and then we say if not data break. That means once we have no more data, once this comes through as having no more data, this is going to keep looping, and once we have no more data from the client, meaning like the client has actually disconnected, that means we can break out of this while loop and jump and continue on saying connection closed, close the connection, and jump back up to the top of the loop waiting for someone else to connect. So once the client disconnects, it's going to terminate this inner while loop, continue on, print disconnected, close the connection, jump up to the top and wait for someone else to connect. But as long as this client is connected, we're stuck on this one client and we can't accept any more clients. So yeah, anyways, after checking to see if the client has disconnected, which is basically what we're doing here, we're going to say and break if they did disconnect, and if they didn't disconnect, we'll take the data that we got here, this connection receive, assign it to this data variable, and we're going to print out the data that we got from the client. So whenever the client sends data to the server is going to print this out on the console. Let's see what else. So we're gonna once we've received the data and printed that thing out, we're gonna, on our connection, we're gonna say send all. This is just gonna send all the data in this variable, basically the exact same data that we got from the client. We're gonna send all, so we're gonna send it back to the client, and then and we're gonna keep doing that. The client can send as much data as they want, and we're gonna keep printing it out and sending it back until the client disconnects, and then we're gonna move on to the next one. So I think I should probably test this out while I'm going to give this a try before we look at the next example. But you'll see here, what else did I want to, oh yeah, so the send all function, this is different. I believe there's a regular send. I never bothered to use it, but there's a regular send function where you can send, check how much data was sent, send more data, and keep going until your whole buffer is used up. Whereas I believe the way send all is supposed to work, I believe this just keeps sending until you've sent all the data in this variable, which won't be much data anyways, because we're sending such a small string. But if it were a larger amount of data, that would matter. So I'm going to exit out of this, and I'm going to run Python 3. I'm going to make sure it's 3. I don't think it matters with my server. But all right, run Python 3. So we're listening on port 1, 2, 3, 4. So we're running our first server. Now I'm gonna connect with a client. I'm gonna try connecting with 2 clients, right? So we're gonna see this is listening. Now I'm gonna connect with this client here, and then I'm gonna connect with this client. And notice it only says connection received. See, and once this one disconnects, this one initiates. See how that worked? We got a connection from this thing. Once it's closed, we get a connection from the second one. It has the same IP address because I'm connecting. Both clients are running on the same IP, so you can't really tell them apart except by their source port. Now you see connection from 127. This is my local host IP address, but the port that is connecting from, the source port, is different from the source port of the other client. All right, so it opens a connection on this source port, closes it on this source port, and then on the second, you can tell this is the second client. Connection from the second client is a different port. It's just one port up and then closed. So the source port would be like 60151, whereas the destination port is 12345, right? So the source port is just a random port that it picks. So this is like the destination port, and this is the source port. But the thing to keep in mind here, I started this client, it immediately sends to the server and comes back, and then it just hangs there, keeping the connection open, but doing a sleep for 5 seconds. Meanwhile, I launch the second client, and it just hangs there and waits, and it can't really connect to the server yet. But as soon as this first client terminates, after that 5-second waiting time, all of a sudden this second client says, hey, now I can connect. It connects, and it sends its data, gets its response back, and we see that logged here. That's why it went in order like this. You see the first client connect and disconnect, then the second client connect and disconnect, right? So we're gonna try that with let's see, kill this server. Just did a Control C to kill the server, and we're gonna look at the code for. So that was server 1. We're gonna look at the code for server 2, and it's basically the same thing except that it uses threads. So all this code up here up top is exactly the same as the first example, except you see I said from threading import thread. So I imported, I believe that's the thread would be the object imported from threading, or in any case, it's imported from the threading library. And let's see here. So we same thing, we print out what we're listening on, but then once we're listening, all right, so we have a function here called def handle connection. We'll get back to that in a second, but that, let's go over that one first, I guess. So handle connection, when a connection comes through, it takes con for the connection that's defined, and it says, while true, it goes through that whole receive, send all thing, the exact same logic from the last example. And once it's done, once the client closes the connection, it'll say connection closed, con close. So it does that. It can take multiple connections this way. And what else? So, all right, this only gets called when a thread for this connection, this is a function that we're using as our thread. So basically, it doesn't run that right away. Basically, after doing this print up here on line 19, it comes down to line 33 here, and it says while true, it does an infinite loop, right? And it does an infinite loop accepting connections. So when one client connects, it will immediately, it prints out that we got the connection, and I think I just printed address and not the port number, but that's fine. And then after accepting the connection, it creates a new thread. So with the thread, we specify the target, which is we specify the name of the function, which is handle connection. That's this function that we just talked about up here, handle connection. And then we specify the argument that we want to send to it. This is how you create a thread. So you say args, and we pass a tuple containing whatever args we want to send to this connection. Now, we're only sending one arg called connection, or called CONN, and that's what we got back. When we accepted, we got an address, so we can get information about what address connected to us, and we got a connection. So we use this connection variable right here, and we pass it to our handle connection function, which is in a new thread. So we create a new thread specifying the handle connection function and the connection variable that we want to send to it. And then we assign that thread to T, so that creates the thread without running it. And then we say T.start, and that starts the thread up. And then we loop back around to the beginning of this infinite loop and accept more connections. So we basically have a loop where accept a connection, then create a thread to handle that connection, to handle all the data passing back and forth between the server and the client. And then we come back around and listen for more connections. So we can keep accepting connections over and over and over again as the thread for each connection runs in the background. So this thread called this function called handle connection will run in parallel in the background while we're looping through accepting new connections. So we have multiple copies of this handle connection function running in the background in parallel, handling connections to multiple clients all at the same time. So let's give this a try and see how this works. So actually no point in writing that, but all right, so we're going to start up server 2. So launch server 2, and let's see here. So we're going to try to launch this client. All right, so client, and then launch the next client. And there we go. Now each client is running up. Client 1 disconnected after, and then client 2 disconnected after a short wait. So we see Python, so we ran and our server is still running, so our server was listening on this port. Now we got a connection from, and I guess when I printed address, it included both of those things, which is, I guess, what it should do. All right, so anyways, here, we don't, instead of seeing, in the previous example, we a connection from one and then closed on that first client. The first client connected, then closed, then the second client connected and closed. In this example, we see the server outputs. We got a connection from the first client, and then we received this data, then a connection from the second client received this data. They're both still connected at this point, and then we see the second client, how about that? It's giving us the port for the second client. I don't know why it's doing that, but I believe because I overwrote the variable. But bottom line, so that looks like a bug in the output, but bottom line, both of these represent both clients disconnecting. So both clients connect first in parallel. So here we have both clients connected at the same time, and then both of them close, rather than them having to go in serial and only having one at a time. So let's see here. We could open up a new window here. CD test 1 and Python 3 client. All right, let's try running 3 at once. Just to see how this looks. So we're gonna run this, this, and this. All right, and there we go. So we see a connection from one, a connection from another, and a connection. So we see 3 connected at once before any of them even get closed, and then after that, all 3 get closed at the same time, which is pretty neat. So that's our multi-threaded server. Now let's take a quick look at inside this server. Hit Control-C to exit out of that, and to kill the server. And I'm going to enter into the code for server 1. And the reason we were seeing that same port, I believe, is because connection close. Yeah, so I guess the variable I'm using isn't thread safe. Maybe. Let's see. All right, so connection closed, S address. So, oh yeah, so I'm using this. This is this is running in parallel. So let's see. Oh yeah, so this address is where am I getting that from? So yeah, ADDR was defined up here. So this variable is whatever the latest client connected to it is going to be assigned to address, which is kind of bad. So when I use address here, it basically it's not going to be unique to this function. I'd have to do something to make that thread safe, but it's just this is the same variable getting accessed from all 3 threads at the same time, or however many threads you're using. So this isn't going to tell you the address of the actual client. This is going to be inaccurate. So that's one bug in this server. So you would want to make this thread safe if you actually use this. So anyways, that's one issue with that, and that's pretty much it. And that's basically all we have to cover with. That's pretty much it for our example. We did a client, a regular server, and then a multi-threaded server. And that's pretty much everything we wanted to cover in terms of this quick little tutorial on Python socket programming, and we covered a little bit of Python threading, but we didn't go anywhere near to in depth with it. But I guess we touched upon it a little bit, which was kind of good. And I think that's pretty much it for today. Hopefully you enjoyed this video. If you liked the video, give me a thumbs up. If you have any questions, comments, criticisms, leave them in the description below. If you want to see more content like this, definitely subscribe to the channel and hit the little bell icon so you get alerts when new videos come out. And as always, hopefully you enjoyed watching this video, and that's pretty much it for today.